Hello class, how you doing? This is Dr. Peoples recording the lesson on your sub work for what, January 24th and 27th, depending on when you look at the video. The sub work is going to be solving rational equations. In order to solve a rational equation, there's a couple of prerequisites you have to be able to do. First off, you have to be able to find the greatest common factor of a rational function. Also, you have to be able to factor quadratic functions. In order to help you with that, I created two videos on YouTube, so there's two additional videos if you want to look at those before you start the solving rational functions portion. And once again, those videos are titled How to Find the Greatest Common Factor of Rational Functions. That's one. Then the other one is called How to Factor Quadratic Equations. Now those two skills you've learned previously in another class, but I just thought you need to brush up on it, so I created two videos just in case you want to look at it. Alright, I'm only doing 4 examples. I'm doing 4 examples on how to solve rational equations. This will be my first example. Problem number 1. So you got 2 over x squared equals x minus 2 over 2x plus 1 over 2x squared. Pretty much the flow for all of your rational equations, the first thing you want to do is find the greatest common factor, which once again is on a previous video explained. So you want to look at your denominators. You want to say, okay, what's my coefficients? What's my common factors between my coefficients? So for my GCF of this, I'm going to say it's 2 and then x squared. So the first thing you got to be able to do is find a GCF between, the GCF of your rational function. So let me move my hand so you can see that. So looking at that rational function, I got to be able to first say the GCF is 2x squared. From there, I'm going to multiply each term by 2x squared. I'm going to show you that in the next step. Alright, looking at my work, you notice in parentheses I put 2x squared. That is your GCF, and I'm multiplying that times each term. So since you see fractions, hopefully you remember when you do a fraction you can actually simplify a fraction. If you see the same thing in your numerator and your denominator, you can cross it out. So what I'm going to do in each term, I'm going to try and cross out things I see. This is my numerator and my denominator. So if you look at the first term, the one with 2 over x squared, you should see x squared in both of those. So I can cancel those two terms. If you look at the next term, you have x minus 2 over 2x. You should see that I can cancel the 2x out. And on the third one, you see 2x squared and 2x squared in your denominator. I can cancel the whole numerator and denominator. So that's what I'm going to do. So on my next step, I'm just going to simplify. Alright, let me explain it a little further to make sure you fully understand what I just did. Alright, so if you look, x squared, right here where you see the 2 over x squared, on the left side of the equation, I canceled out x squareds. So if you look, all I have left is a 2. And then I have that 2 in parentheses, that's the one that I have left over. So let me show you this. That's basically what I did. I canceled out my x squareds. Hopefully y'all can see that. Alright, so all I have left is 2 multiplied by 2. Alright, in this term right here, which I have I'm going to put my marker near it. Alright, well, right here. You see that 2x squared? I'm going to simplify that. X squared, 2 and 2 will cancel out. Then you have x squared over x. Now if you have x squared over x, you know that that's going to leave you with the x. If you divide x squared by x, all that's left is the x. So I'm going to simplify that as well. So you notice in this parentheses over here, I have left. Let me slide this up, make it bigger for you. I have x parentheses x minus 2. The reason being is because 2 goes into 2 one time, and then x divided into x squared leaves you with just the x. And that's just simplifying exponents. X squared over x is x. Alright, the last one, if you look over here on the right, the last term, you have 2x squared and 2x squared, and y'all know that cancels out. That's 1. So all you have left is the 1. Alright, and that leaves us with this portion over here, the 2 parentheses 2 times 2 equals x parentheses x minus 2 plus 1. Now if you understand that, the rest is pretty easy. It's just solving an equation. So I'm going to next simplify 2 times 2. Distribute x. So I'm going to have x times x. Then x times a negative 2. So my next answer should be 4 equals x squared minus 2x plus 1. So this is what you would have, 4, and you get the 4 by multiplying 2 times 2. Then x times x gives you x squared, x times negative 2 gives you negative 2x, and I brought down my plus 1. Now you did a couple of worksheets the last week, how to solve equations, and that's all this is solving an equation. So you got a 4 on the left side. I'm going to move a 4 over to the right by subtracting 4, and I'm going to subtract 4 from the 1, which is the like term. So subtracting 4, I'll show my work. So this is what we did. Subtracting 4. The reason we're doing that is because we want 0 on the left side of the equation. And y'all know 1 minus 4 is going to be negative 3. So everything else comes down. So let me show you my next step. Alright, so I have 0 equals x squared minus 2x minus 3. Now, pretty much this problem uses a lot of skills you've learned in previous classes. At this point, we don't have the answer, but we do have a simplified equation. If you remember how to factor, which is another skill I told you need, it's a prerequisite. All you have to do is factor this. Now you see the minus 3 at the end, so you know the only way you can get 3 is by doing 3 times 1. So I'm going to do my parentheses for factoring this. The correct factorization for that is going to be x minus 3 and x plus 1, both in parentheses. And you remember you can check this by using the FOIL method. Now once again, if you have any problems with factoring, you need to check the other video on how to factor quadratics. Alright, now at this point what you do is you set both of your solutions. X minus 3 equals 0, x plus 1 equals 0. And then you simply have your answers. Alright, so I set them both equals 0. And then y'all know the last thing is to solve your little mini equations. Do plus 3 on both sides on the first equation and minus 1 on the other one. Alright, So we have our answers. X equals 3, x equals negative 1. Now let's talk about our solutions. Now the last thing before you actually say those are your answers, you must plug them back into your equation to make sure they're true. Alright, the reason being there's something called an extraneous solution. Now it's possible for you to get two answers, but one of them can be an incorrect answer, or what we call extraneous in math, which means an extra answer. It's not really a solution, but it is. They call it extraneous in math. So you want to plug both of those back in, make sure it makes the equation true. I actually already plugged them back in, but you can do this on your own later on. I plugged them both in and they both check out. And when I say check, you know that means the left side equals the right side of the equation. Alright, so for that problem 1, you have a good example. You have two answers, x equals 3 and x equals negative 1. And I know that took a little while, but that's probably the easiest type problem we can do for rational equations. From there, we're just going to be doing similar process, but you know, it could be more complex. That's about it. Still might be factoring. You're still going to do the GCF. None of that changes. All right, let's do problem 2 then. Once again, you have any issues, you can always email me at my email address, or you can just respond to this YouTube video. I'll monitor it. Each day I'll look at it and just see if you have any questions. Now, you're still responsible for the homework and the classwork, so don't think you email me and you don't do the work. Alright, problem 2. Alright, problem 2 is 2 over 3n equals 5 over n squared plus 2 over n squared. Alright, first step is to first find your GCF. Alright, looking at the problem, you should see you have a 3 and a 2 as your coefficients in your denominator. So since you have 3 and 2, you know that the common factor between 3 and 2 is 6. So that's the first part of your GCF, 6. And then you want to look at your highest exponent. You have n squared, so you want to take that. So your GCF for this problem is going to be 6n squared. I'm sure y'all are aware that if you miss the GCF, more than likely the rest of your problem is wrong. So it's very important, if you don't understand how to get GCF, you go back and look at the video, how to find the GCF for rational functions. It's about a 15-minute video, so that'll be a good resource for you. Alright, once you find 6n to the second power, you want to multiply it times each term, and then do your simplification process again. And I'm going to show my work. Alrighty. Looking at my problem, I wrote 6n to the second power outside each term. So if you look at your original problem, you see that I have the terms this time in the parentheses, and my GCF is on the outside. Now I'm going to start simplifying that. The first term, if you look at the one that's 2 over 3n, you see that 3 is in your denominator, 6 is in the numerator on the left. You know 3 goes into 6 2 times. So 2 is going to be left over. And then you see you have an n squared over n. Y'all know, hopefully, that's going to be n. N squared over n equals n. All you're doing is subtracting the exponents. That's basic property of exponents. Alright, so that's simplifying the first one. So 3n is going to be left on the outside. Now looking at my second term, the one with 5 over n squared, you notice I don't have a coefficient in my denominator. So I can't divide 6 by anything. So 6 is going to be left over. The n squares are going to cancel. So all you're going to have left is 6. So for your second term, you should see you're going to multiply 6 times 5. the third term where you have 2 over 2n to the second power, you see there's a 2 in the denominator. So I'm going to divide 2 into 6, leaving you with a 3. And then the n squares cancel. So you're just going to have a 3 on the outside of that. So let me show you visually what I just said. Alright, so I've shown my work. Once again, simplification. If you need to rewind a video, you can always do that. But I have a 2n on the outside, multiplied times 2, which is going to give me a 4n. Then 6 times 5 is 30, 3 times 2 is 6. So I'm going to write that in my next step. So I have 4n equals 30 plus 6. This point, all we're doing is simplifying. It's a two-step equation. Move everything to the same side of your equation. Since I have my variable on the left side, actually, I'm not going to do that because it's to the first power. So I'm going to solve it where I have all my variables on the left, all my constants on the right. So I'm just going to say 30 plus 6 equals 36, then divide by 4. Alright, show up my work. Answer should be n equals 9. Alright, 30 plus 6 equals 36. Divide 36 by 4 gives you 9. Alright, now just talk about this. Let me show you the answer again before I talk about checking, because it's important you check. You're always going to check, I'm going to say it multiple times, for your extraneous solution to make sure that your solution is actually correct. Alright, even though you got the answer, you want to make sure it's not extraneous. Now in an assessment, if you put an extraneous solution as your answer choice and you don't put extraneous, it is wrong. Alright, plugging in, let me just verbally tell you how you can check your answer. Hopefully you see if the original equation, if I plug in a 9 in my denominator, on the left side I'm going to get 3 times 9 is 27, so it's going to be 2 over 27. If you plug in a 9 where n squared is, you should see that's going to be 81. And then n squared will be 81 times 2, which is 162. And I did this on my little sheet of paper earlier. So let me zoom in so you can see that. Alright, so you see me checking it. 2 over 27 equals 5 over 81 plus 2 over 162. Two ways you can do it. You can plug it in the calculator and see that it equals, or you can do like I did. I used fractions, found the LCD, and I just checked it. Either way, it gives us the answer. We just want to make sure it's right before we move on. Alright, so it checks the left side equal to the right side, so we know it's a true solution. It's not extraneous. Alright, so I did example 2. That'll get you through most of that worksheet. Now there's some more advanced problems I got to show you. Let me erase the board and start over. There's some problems where you're going to have to factor, and then from there, after you factor, you're going to have to cancel, just like you did here, but it's going to look a lot different. Now, if you run into issues, the major issue might be the fact that you don't remember how to factor. And I keep saying it over and over, but if you don't know how to factor, you're probably going to have difficulty solving rational equations. You really need to get a handle on that. Alright, let's start with, here's what I'm going to do. I did example, or problem 14 on worksheet number 1. So on one of your worksheets for your sub work, this is problem 14. And I'm going to work through that. Now, because I'm showing you every step, it is going to take this whole board. I might have to erase and keep going. And I don't mind doing it. I just want to make sure that since I'm not in school and you can't ask me a question, that you can at least have some solid examples. Alright, this is 14. 5x minus 20 over x squared minus 9x plus 18 plus 1 over x minus 6 equals x minus 4 over x squared minus 9x plus 18. Alright, your first step. You want to factor everything. Everything you see that's to the second power you want to factor. So that x squared minus 9x plus 18, you first must be able to factor that. Now you know 18, there's only so many ways you can multiply and get 18. You can do 1 times 18, 2 times 9, 3 times 6. That's your possibilities. Now, to get the right answer, you want to say to yourself, how can I get 9? Alright, and once again, I'm not going to go into great detail on the factoring. You just look at the video if you don't understand that, how to factor. So I'm going to put x minus 6, x minus 3 right there, factor that correctly. So that's my first step, factor. Now you must do that in order to get your GCF. Before you even figure out your GCF, you first have to factor. Alrighty, so I factored correctly. Now after you factor, your next step is to say to yourself, you don't want to worry about in the denominator what repeats. You want to say, okay, what do I see in my denominator? Alright, you see x minus 6 3 times. Alright, so x minus 6 is part of your GCF. And you also see you have x minus 3 twice. You don't write it twice, you write it once. So because you see x minus 6, that's the first part of your GCF, x minus 6. The second part is x minus 3. So all you do is write GCF x minus 6, x minus 3. Wow, that's your GCF right there. Alright? No, it looks weird, but that's what it is. It's going to make sense in a minute. Now what you want to do is multiply that times each one of your terms. So x minus 6, x minus 3 is multiplied times each term. And we're going to start simplifying. It's a lot of stuff to write, so give me a second. Alrighty, there we have it. Hopefully you see that. Let me slide that back so you can see all that. Alright, what I've done is I put x minus 6, x minus 3 times outside as my GCF. And now that's the hardest part, really. Now what we're going to do is cancel out. In your first term where you see that 5x minus 20, you see that x minus 6, x minus 3 is in your numerator and your denominator. So that means you can cancel them out. So pretty much everything's going to disappear to the left of that 5x minus 20 and below it. Alright? Looking at your second term, you see that 1 over x minus 6. You should see how you have x minus 6 in your numerator and your denominator. X minus 3 is going to be left over. In your third term, which is the one that says x minus 4, you see that x minus 6, x minus 3 is in the numerator and denominator, so it cancels out. So watch what I'm going to do. I cancel out everything that I see in my numerator and my denominator. Alrighty, that's what I've done. Now let me get you to focus on the canceling out again. You see how that 5x minus 20 on the left of that, I canceled out all that. X minus 6, x minus 3, and below it, x minus 6, x minus 3, it cancels. You see at the second term, I canceled out x minus 6. I couldn't cancel out the x minus 3 because it's not in the denominator. So I just leave that. And then if you look at your third term, x minus 4, you see how I have x minus 6, x minus 3, and x minus 6, x minus 3 in both the numerator and denominator? It cancels. So all you have left, see how I have left? 5x minus 20. I have x minus 3 I brought down because it didn't cancel out, and the 1. Then I bring down the x minus 4. Everything that's not canceled comes down. Let me show that again, so just in case you didn't get a look at it. So you have 5x minus 20 plus x minus 3. 1 is brought down. Then you have x minus 4. Alright. Now what we're going to do is start solving this equation. And I'm showing you every step. Give me a second to erase some of this. Alright. That's where we're at right now. 5x minus 20 plus x minus 3, 1. Alright, what you want to do is start simplifying. Now that 1 I will multiply times the x minus 3, but you know 1 times x minus 3 is just going to be x minus 3. But if it was a number like, say, 4, that means I would have got 4x minus 12. But in this case, I'm going to just bring it down, x minus 3. So my next line should look like this. Alright, so all I did in that was distribute to 1. And then now at this point, what I'm doing is I'm solving this equation. You see how you have 5x and x on the left side? Y'all know 5x and x is going to be 6x. I have negative 20 and negative 3. You know that's negative 23. It's on the same side of the equation, so you don't do no plus 20 or anything. You just collect the like terms. So it's going to be 6x minus 23 equals x minus 4. And once again, all I did was collect like terms in that step. Now, if you look, you see you have a x on the left, or 6x on the left, and an x on the right. You want to bring those two things together. The only way you can move anything from the left side of the equation to the right is by canceling it out. So what I'm going to do is I'm going to subtract x on the right to make that little x disappear, and subtract x from 6x. Alright, that's my next step. Subtract x. Now you see that all we have is a two-step equation. 5x minus 23 equals negative 4. This should be simple at this point. If you add 23, you can cancel out the minus 23. So I'm going to add 23 on both sides. I have 5x equals 19. Now, if it was 5x equals 20, y'all would know the answer is x equals 4. But since it's not 20, we can't just say it's 4. You divide 5 into 19, and it's actually a fraction or a decimal. Just leave it as a fraction. So it's going to be 19 over 5. Alright, so it's x equals 19 over 5. Now for checking it, you might want to convert to a decimal, but I checked it with a fraction and it worked out. You want to check to make sure it's not extraneous once again. Okay, so that was number 14 from worksheet number 1. Now if you're feeling good about yourself, you think you can do your work, you probably can go ahead and cut off the video now. I'm going to do one more example just in case somebody needs additional problem. Put in notes. then this will be the last problem I do. Alright, on worksheet number 2, I'm going to do number 10. It's pretty similar to the last one I just did, but you know me, I like to have multiple examples. One thing, we don't have a textbook. 2, I'm not in class. So I want to make sure you have every opportunity to learn something. Alright, this is problem number 10 from worksheet number 2. Let me write worksheet number 2 on there. Alright, so worksheet number 2, number 10. Alright, once again, so following the same process, the first thing you want to do is factor. Everything that's to the second power, you factor. So that means that a squared minus 4a minus 12, I can go ahead and factor that. That looks like it's going to be what? A minus 6 and a plus 2 on the top. On the bottom, you know it's going to be a minus 5, a minus 5. Now, you might not have got the answer as fast as I did, but in the end, what you want to do is take your time. If you have to go through and list out all your factors, that's fine. Your job is to be able to factor correctly so that you can get your GCF. Okay, I factored, I showed my work. Now, looking at your denominators, you see you have a bunch of a minus 5s. The first term on the left has 2. The second term with the 6 on the top has 1 in the denominator. And the last one, a minus 3, has 1 in the denominator. So that means your GCF is just going to be a minus 5. Not a minus 5, a minus 5. You don't write it twice. You don't write repeaters. You just write what you see the first time. If it repeats, you just write it once. So we got a minus 5. Oh, let me rephrase what I just said. I said you don't write it twice, and then I wrote it twice. You got to write a minus 5 twice because it is your greatest common factor for your biggest denominator. Because if you look at the one that's on the left, you see that a squared minus 10a plus 25. Your whole goal, and the reason you're doing this, the whole goal is that you have no denominators. If you write it twice on the left side, you would still have an a minus 5 in your denominator. So when you look at that one on the left, that determines that I got to write it twice. Hopefully that makes sense to you. So you always want to look at your quadratic, your highest exponent, to see which one you're going to write twice. If you write twice, in this case, it repeated. That's the first one we had to repeat it too. So, alright, what I'm doing now is I'm writing a minus 5 over each one of these. And then I'm going to start canceling out. Running out of space, of course. Alright. Now let me show you this and let's talk about it. Or let me just tell you about it. I guess we can't talk. Okay. Looking at your first term on the left side of the equation, you have a minus 5 in your numerator and denominator. So you know that disappears. The whole point of us doing this GCF thing is so we have no denominators. Alright, so we must write a minus 5 twice. It's going to cancel out your numerator, your denominator. So that means these two disappear. And I'll show you step by step. It'll look better that way. So you see how I cancel out a minus 5, a minus 5? All you have left is a minus 6 on a minus 6, a minus 2 in your parentheses in your numerator. Now looking at your second term, the one with the 6, only one of the a minus 5s disappear, because that's all this is in your denominator. So I'm going to cancel out one of them, not both of them, because I only have one. So you should see you have a minus 5 left and 6. That's what I'm going to bring down in 1 second. In your third term, you have a minus 3 in the top, and then your denominators, you're going to cancel out the a minus 5 and one of the a minus 5s. Alright, and I'm going to write what's left over. All we have in our first term is a minus 6, a minus 2, then we have a minus 5, parentheses, and then we have a 6, then we have plus a minus 5 and 3. At the very bottom is what we have left over. Alright, and that's after we cancel out what we had in the top and the bottom for our numerator and denominator. Now if you understand that, the last step, the next thing to do is you see you have a minus 6, parentheses, a minus 2. You can FOIL that. And actually you had the answer up here. You say you had a squared minus 4a minus 12. That's the answer. So I'm just going to write that back. Then I'm going to distribute the 6. Second term, you see you have a minus 5 and then you have 6. So I'm going to distribute 6 times a, then 6 times negative 5. Then in the next one, you see you have a 3. So I'm going to do 3 times a, 3 times negative 5. So I'm simplifying my problem, getting rid of my parentheses. Give me a second, clear my board, and I'll start that. And pretty much after you do that, all that's left is factoring and solving for the answer. Well, let's see what happens, because every problem is different. I'm thinking that's what's going to happen, but I could be wrong. A squared oh, let me make sure I write that right. That was a squared, a minus 6, a plus 2. I think I wrote minus 2, but it's supposed to be a plus 2. Alright, so when I multiply back, this is what we get. Okay. So what I did is I went from the bottom, a minus 6, I FOILed that, and then I distributed to get the number at the top. So you see I have 6 times a, 6 times negative 5 gives you 6a minus 30. That's how I got that at the top. 3 times a, 3 times negative 5. That's how I got 3a minus 15. So hopefully we understand how we got that portion of the problem. Now what we're going to do now is I think I wrote the problem wrong, guys. Well, that wasn't good. I'm going to see if I can edit the video, but I hate to start over. Jesus. The problem for worksheet number 2 was supposed to be a A minus 3. I think I just wrote 3. So let me go back and start some of this over. Now I could have finished that problem, it just won't match up to your problem from your worksheet. Alright, I'm going to let me go ahead and start where you had the GCF part. Alright, so what I'm going to do is I'm going to start where you had the GCF. And I guess I wrote the problem wrong. I want to revise that so you don't have the answer wrong for your assignment. Alright, let's start from here. Alright, and I don't know if I wrote the A minus 3 or not over there, the last term. Everything is the same. The only thing is I think over here where my finger is, I'm thinking I didn't write the A minus 3. Alright, maybe I did, maybe I didn't, but let me rephrase what I did if I didn't. Let's just make sure it's right. So I'm going to cancel out again. I'm going to do all my canceling. So this should look exactly like what we just did. I'm going to bring down my A minus 6, A plus 2. Bring down my A minus 5 and my 6. Bring down my A minus 5 and my A minus 3. So I got A minus 6, A plus 2 equals A minus 5, 6 plus A minus 5, A minus 3. Now this is the difference. In my last problem I didn't have this part, and that's what kind of bothered me. A minus 5, A minus 3, that's what I should have had. That's the only thing we really need to change that last term. It should be A minus 5, parentheses A minus 3. And we're going to have to FOIL that. So I'm going to FOIL the A minus 6, A plus 2, which give me the A squared minus 4A minus 12. And then distribute the 6. And then FOIL the last two terms, A minus 5, A minus 3. Give me a second. I'll talk as I do it. Hopefully you're writing as well. So I got A squared minus 4A minus 12 equals 6A minus 30. And then foiling that last one, A times A is going to be A squared. And then you got minus 5 minus 3, that's going to be negative 8A plus 15. Alright? Now if you do the FOIL method, this is what you would have came up with. Alright, at this point what we're going to do, you have a whole bunch of terms that need to be simplified. You see on the left side everything is pretty much simplified. On the right you have 6A and you have negative 8A. So 6A, negative 8A, oh I keep messing that up. 6A minus 8A is going to give you negative 2A. Those are like terms. And I'm going to put a little shape by them just so you can see it. Put a little dot for those like terms. I'll put a triangle for the constants. So you should see how you have 6A minus 8A is negative 2A. Then negative 30 and positive 15 is going to be negative 15. So I'm simplifying the right side. Okay. I've simplified it. Now what you're going to do is you got to move everything to one side of the equation. That's what you want to start doing. But then again, if you look at it, if you subtract a squared from the right side to the left side, you should see they cancel out. Alright, so that's the first thing I'm going to do. Do negative 8a squared. And you see those cancel out. So the moment they cancel out, you don't have any more squares. All you have left is negative 4a minus 12 equals negative 2a minus 15. Alright, at this point, what you want to do then is say to yourself, okay, how can I solve this problem? If I move all my a's to the left and all my numbers to the right, or constants to the right, I can divide and get my answer. So I'm going to do plus 2a on the right and the left. Alright, so if we do plus 2a, you should see it's going to be negative 2a minus 12 equals negative 15. That's what I'm going to write next. Negative 2a minus 12 equals negative 15. Alright, and all I did once again was add 2a on both sides to get that negative 2a minus 12 equals 15. The next step will be to add 12 on both sides. Then, obviously the last thing is divide by negative 2. So I'm going to do plus 12. So I got negative 2a equals negative 3. Then divide by negative 2 and we're done. So dividing by negative 2, you get a equals positive 3 over 2, or it can be in decimal form 1.5. Alright, and you can check it to make sure it's not extraneous. I already did, so I know it's not extraneous. But you want to make sure you check every last one of your answers to make sure you don't have an extraneous answer. Alright guys, I did 4 examples, almost 5, because I kind of messed up on one of them when I wrote the problem. Alright, but I hope I helped you with your assignment. If you have any questions, you can respond to this YouTube video, or you can email me at my Clayton County email address. Alright, hope that helped, and have a good day.